Hello everybody. In this video, we will discuss what synchronous and asynchronous processes are. Along with that, we will be touching upon multi-threading and multiprocessing and what async libraries in Python, some of its key concepts like what coroutines are, what tasks are, what futures are, what event loop is, and what is its await functionality. So let's start with asynchronous and synchronous processes. So synchronous processes are those processes that are executed sequentially, one after the another. So once one process is complete, then only you move to the next process, and they can't happen at the same time. They are happening sequentially. Whatever functions you write in Python, let's say you wrote two functions, def add, this one adds x and y, and let's say you wrote another function def sub that takes two arguments x y and returns x minus y, and then you are calling both of these functions, let's say on 3 2 and this one as well on 3 2. So whatever functions you write in Python, they all are synchronous. They can be executed one after another. Once you add 3 and 2, then only you move to sub function and subtract 3 and 2. It's not like addition is happening and subtraction is happening parallelly and you are getting the results at the same time. First you are getting 5 and then you will get 1. Okay, so this is synchronous, meaning they are happening sequentially one after the another. While on the other hand, asynchronous means that processes are happening simultaneously. By that I mean at the same time. So there are two things that can make that can make two processes asynchronous. Either they can be executed concurrently or parallelly. We discussed what's the difference between concurrency and parallelism in our first video. You can watch that video. So concurrency, it's not true parallelism, but it's give you an illusion that tasks are happening at the same time. Okay, so they might not be happening absolutely in parallel, but they have overlapping time periods. Okay, so that is what concurrency and parallelism is. So asynchronous processes are those processes that happen simultaneously at the same time. Okay, they can't be executed sequentially. Okay, for example, let's say there is add and subtract, and using the async library in Python, you made these two tasks asynchronous. So what will happen, that you can execute these tasks simultaneously, and if you are using asynchronous by multiprocessing, then you can get the result at the same time. We will discuss what multiprocessing and multithreading is after some time, but I hope the difference between synchronous and asynchronous processes is clear. So I am summarizing it. Synchronous processes are those processes that happen sequentially, and asynchronous processes are those processes that happen either concurrently or parallelly. In short, they happen simultaneously. Every function that you write in Python is synchronous, but you can make them asynchronous using async library in Python. So this was what we have discussed till now. Now moving forward, we will discuss what multithreading and multiprocessing is. So multithreading means you are using multiple threads. Okay, for example, whenever certain kind of processing happens, like for example you are calling these two functions, this is happening in a single thread, right? Because you haven't added any kind of overhead over it, like async library or threads processes. You haven't done anything extra, right? So this is happening in a single thread. In CPU core, this is my core, it's happening on a single thread. If you want to understand the difference between threads, pools and processes, I have made a video on my channel. Please go and watch that video. So most of the process happens on a single thread. But what if I make it multi-threaded? For example, addition is happening on one thread and subtraction is happening on another thread. Now there is a catch here. In Python, you have global interpreter lock that we discussed in the previous video. So because of this global interpreter lock, the interpreter is locked as long as processing in one thread is happening. Once that processing is complete, then only the interpreter unlocks and it moves to the next thread and execution happens there. Okay, so Python, though the processes can be done in multiple threads, but it's actually executing synchronously. It gives you an illusion that okay, since I am doing the processing on multiple threads, it must be asynchronous. But in reality, because of global interpreter log, it's actually synchronous. Okay, so it can't happen that you are using addition on we, and mind you, we are in the single core. It's not like I'm using multiple cores, I'm in a single core, and within that single core there are two threads. So it's not like addition is happening on one thread and subtraction is happening on one thread. You will get 5 and 1 results at the same time. That will not happen. So whatever thread is executing first, let's say addition is executing first, so interpreter will complete the execution here, then only it will unlock and move to the next thread, and then the result will be then you will get the result for another thread. Okay, so this is what multi-threading is. Instead of doing all the processing on single thread, you break the tasks and mm, in multiple threads the processing happens. Okay, so this is what multi-threading is. And what multiprocessing is, that you are not restricted to one single core. So this is core 1 of your CPU and this is core 2 of your CPU. I have explained in detail everything what threads, processes and CPU are in my previous video. Please go and watch that video in order to clearly understand what I am saying in this video. So multiprocessing means that processes are happening in multiple cores. Okay, so addition is happening here and subtraction is happening here. So this is actually what true parallelism is. Why? Because interpreter here is independent of the interpreter here. This is truly independent of each other. So if you are executing processes on different cores, then you will get the result at the same time. You will get 5 here and you will get 1 here, both executed at the same time. This is what true parallelism is in Python. Okay, so Python can't be multi-threaded if the threads are on single core, but if threads are on different cores, then it will be multi-threaded and it can happen parallelly. But if we forget about threads, then if the processes are happening on multiple cores, let's say one process is happening on one core, another process is happening on another core, then that becomes multi-processing, and this is true parallelism. Okay, things are happening at the same time, things are happening parallelly, things are not dependent on one another. The interpreter that is here is independent of the interpreter here. But if you are using multiple threads in one single core, then that interpreter will be logged for until the execution in one thread is complete. I hope the difference between multi-threading and multiprocessing is clear. Now let's move to the last topic of this video. I am not giving code examples in this video. If you want, then do let me know in the comment section. I will make one video on code examples as well if you want. So asyncio library in Python helps you achieve asynchronous tasks asynchronously. Okay, so there are four main functionalities, actually five main functionalities of Asyncio. We will discuss each one of them. First one is coroutine. Coroutine. So just like above, you defined def add, you defined this function, right? Def add, taking two parameters x and y and returning x plus y. So this is a simple function. But if I just use this library, then there is a keyword in this library called async. And in front of any function, if I use async, then this function becomes asynchronous. Okay, and this function, since it's not executed anywhere, it will be called coroutine. It's just the same thing but different names. Okay, now you are calling it coroutine. Instead of calling it a function, you are calling it coroutine. That's the only difference. Now this coroutine can be executed only by awaiting. For example, I say await add xy. I'm not writing the exact syntax, but just to give you an example that you use await keyword to run this coroutine. Either you can use await functionality or you can wrap it around a task, which is our second important keyword in asyncio. So when you wrap a coroutine as a task, then what happens that they can be executed asynchronously. By simply using await in front of coroutine doesn't make it asynchronous. It will still be synchronous. Okay, but if you wrap this coroutine around a task, then that can be used asynchronously, that can be executed asynchronously. Okay, so let's say you have two functions, add and subtract, or rather I should say coroutines, add and subtract. Then what you do, that you make them task. Okay, and there is dot task. I think there's some function like this. If you want coding examples, then do let me know. Now what this does, that it makes these two functions tasks. Now these tasks are then handled by event loop, which is our third functionality of Asyncio. Event loop is like a manager. It's like a manager. What it does, that it schedules these tasks and waits for one task to complete. It's not like it's actually waiting. It let it run and it move to the next task. Once the execution of first task is done, it executes the another one, and once its execution is complete, it moves back to the previous task and get the result. Okay, it's like a manager that pick tasks based on its execution. Okay, let's say there are two tasks. I'm just giving you an example to make it more clear. Let's say there are two tasks, task 1 and task 2. Okay, so what it is doing, that it's letting run task 1. It's running and it's running. Okay, it's not waiting here. It's moving to the next task and asking it to run. It's running. And once task 1 is complete, it will collect the result and it will move back to the task 2. So this is what asynchronous processes are. Happening concurrently, right? Happening concurrently, not happening sequentially. But this event loop is managing everything. How would Python know by itself that once task 1 is done, it will move to the next task, right? That is how it happens sequentially. But how will it know that I have to also run task 2? That is where event loop comes into the picture. It's like a manager that manages all the tasks and it makes sure that tasks are getting executed asynchronously. Next term is futures. It's like a placeholder for your result. Just like when you are defining a variable, you simply write x, and let's say you just say okay, it's an empty string, and once the processing is done, you are actually replacing x with the result. Okay, so it's like a placeholder. It has, you don't explicitly define futures in Asyncio library, but it's an important term to know. It's like a placeholder for your result. Okay, just like you have variables as your placeholder for certain quantities, similarly for your results of coroutines, you have futures. These are the placeholders. Okay, and the last important keyword in Asyncio library is await. Await, I already told you here, because of this await functionality, event loop knows that okay, I need to wait here and move to the next task. For example, there is a coroutine defined, let's say xy, and I say await here for 2 seconds. I'm not, again I'm telling you, this is not the exact syntax. If you want, I can make another video on code examples where I will tell you how to exactly use these keywords. But let's say I'm just explicitly saying that you need to await here for 2 seconds, and then you need to return x plus y. Now there is another function defined, async sub xy, that returns x minus y. So event loop will enter here. It will see okay, await is there. So what it will do, that it will suspend it tasks and it will move to the next one until these 2 seconds are over. And once these 2 seconds are over, it will move back to the task, gather the result, and then it will come back to this function if its execution is not complete. If it's complete, then it will terminate the task. That is how the whole process is. Coroutine is nothing but a simple function that is asynchronous. So instead of calling it a function, you call it coroutine. Now coroutines can't be executed asynchronously until you await them or you convert them into task. So whenever you wrap a coroutine around a task, that is when you can run it asynchronously. Simply using await functionality in front of coroutine doesn't make it asynchronous, it is actually synchronous. But when you wrap the coroutine around a task, then event loop knows exactly that okay, here I need to wait, here I need to suspend this task and move to the next one. So that is how you exactly run your processes asynchronously using the async IO library. And event loop is like a manager that that juggles between the tasks, and whenever it sees that okay, there is an await keyword that it can see, then it suspends that task and move to the next one. And once the execution of the first one is done, it waits. Okay, waits for that task to complete, but it doesn't completely suspend other tasks, it let other tasks run. And future is just like the placeholder for a result. Once you get the result, you replace it with that. If you have any kind of doubts, then do let me know in the comment section. I will be happy to clear all your doubts. This was just a small introduction of what asynchronous, synchronous, multi-threading, multiprocessing, and async IO library in Python is. And I haven't given any kind of code examples in this video, but if you want, then I can make a video on that as well. In the upcoming videos, I am thinking to cover MCP, Model Context Protocol. It's a very interesting topic, and over the past few months, I have seen its boom. So, I am planning to make a video on that, and I will make sure that you don't need to see hundreds of YouTube videos for understanding what MCP is. In one single channel, on my channel only, I will provide you enough resources that makes it clear what MCP is. So, do subscribe to my channel and wait for MCP video to come. Thanks.